So thanks, Ruby, again for this great session. And now it's time for the next session. So please join in hands welcoming Deeptendu. Um, so I'm sure that most of us have come across a piece of code that just made our brains churn. All the modern programming languages like C++, Java, Python, and JavaScript, they support object-oriented programming. But some of us who aren't as smart as ChatGPT, we really struggle to understand the basics of programming. But worry not, we've got an experienced programmer among us who's Deeptendu, and he's a budding writer. He's here to help us understand the basics of object oriented design. So please welcome Deeptendu Ahuja, who's primarily a software developer in the networking domain, working on C++ over Linux platforms. And the fun fact is that he's an MC and also a singer. So over to you, Deeptendu.
Thank you so much, Anshita. First of all, a very good morning to one and all present here. It is an absolute honor to be in this august company of technical writers. What a phenomenal growth this community has seen in just 2 years. When the whole world was locked down, you guys had your own plans, and I'm so glad to see that a community has grown so rapidly and is almost pan India and covering members outside of India as well. So congratulations to Technical Writers Tribe. I hope the tribe continues to grow. And yeah, so object oriented programming, this is the topic of my presentation. Well, we can be really proud, us technical writers, we can be very proud, because if there wouldn't have been any English language, C++ and Java and JavaScript could not have been developed. After all, the building blocks of all humanity, of all communication, is English language, and that is the tool with which you work. Yes, you might be using your Adobe tools and XML tools and whatnot, but at the core of it is language. And object oriented programming is at the heart of all the software revolution, all the IT revolution that is taking place today. If you are working in an embedded systems domain, for example, in companies like, say, Cadence or Sienna or Synopsys, Mentor Graphics, companies like these, which are building embedded systems, microprocessors, FPGAs, there the code is primarily written in C language. But of course, having the skill of object oriented analysis and design would help us write better documents in those domains as well. But apart from that, any domain that you talk about, be it cloud computing, be it application, any sort of application development, they are written in some programming language which is object oriented. It could be C++, it could be Java, it could be Python or JavaScript, which is the heart and soul of web development. So even that is an object oriented programming language. My goal with today's session is just to harp on this word object, object oriented, attributes of an object, functions of an object, object interaction. I'll just keep repeating these words over and over and over again for the next 30 minutes, so that next time when you sit to write a document, you think in terms of objects, that you ask the SME, or you ask yourself, what are the objects that I'm dealing with, what are the attributes of that objects, what functions that object can perform, and how is that object interacting with other objects in the system. So and that is my goal, and I have laid it out bare in front of all of you, that what I'll be doing for the next 30 minutes. All right then. So let us start with some definitions. So object-oriented analysis is the procedure of identifying requirements and developing specifications in terms of a system's object model, which comprises of interacting objects. In object-oriented approach, requirements are organized around objects which integrate both data and functions. So Grady Booch, who is the father of object-oriented programming paradigm, has defined OOA as method of analysis that examines requirements from the perspective of classes and objects found in the vocabulary of the problem domain. The attractive word for me here is vocabulary and problem domain. So we should be able to understand the problem domain, write about the problem domain in our own words, and then start analyzing the problem domain to identify objects and the relationships between them. That is the whole purpose of object oriented analysis. So what do we do as part of object oriented analysis? We identify objects, we create an object model, we define the attributes of that objects and the behaviors of that objects, and also describe how do various objects interact with each other. All right, moving on. So there is some interesting statistic that I have come across on the internet, that the ratio of technical writer to software developer in an organization could be something like 1 is to 10, one writer per 10 software developers, or one writer per 20 or 30 software developers, depending on the organization, depending on the kind of project. Now, why is this statistic interesting? Because every software developer, say you are working in a company like Interglobe or in a company like Make My Trip, where you are designing, developing, where the company designs and develops ticketing systems, reservation systems for airlines, hotels, trains, etc. Now, if there is one technical writer for say 20 developers, those 20 developers are working on 20 different modules of that Make My Trip system. Each of those modules, I'm certain, uses object oriented analysis and design. And one sole lonely technical writer is supposed to crystallize, encapsulate all the information, all the work of those 20 engineers into one cohesive, understandable, easy to read technical specification or technical document for Make My Trip. And this is just an example. Feel free to think about other examples or other scenarios in your head. So, what I want to arrive at is that a technical writer has to think about the entire system, and the system is comprised of many modules which are based on object oriented programming fundamentals. So according to me, it makes sense that if the technical writer also applies object oriented mindset to creating documents, or to or to reading existing documentation, the quality of the work product, the quality of the documentation can drastically increase. So this is the whole rationale that I'm coming up with. Because we are working as software developers, I work on 2 to 3 modules in my company. Each of those is written in C++ language, so I'm dealing with objects and classes all day long. And then the technical writer not only writes about the piece I was working on, but 10 other people like me, and makes a wonderful document that the customer can understand. So, SDLC, as you all know, is analysis, design, writing. Yes, software development is also writing, but we write code in C++, Java, and Python. And of course, the next step is to test and then deploy the software. Whereas the DDLC, the document development life cycle, is again first about analysis. This is where you employ strategic thinking. This is where we beat tools like ChatGPT, because ChatGPT can give us answers based on its experience, but we can do strategic thinking. So yes, analysis, then we design our document, and then we write. The difference here being that we write our documents in English language, we get it reviewed from peers and seniors, and then get it published. So writing is involved both in software development and in document development. It is just that the language in which we are writing is different. I know it is obvious, but I just wanted to put it out there for some perspective. So moving on, there are various kinds of technical documents that we typically see. There could be an overview guide, a quick start guide. There could be tutorial documents, some conceptual documents, how-to guides, reference guides, and API documentation. We are living in the world of APIs today. So many startups are built on APIs, and they expose APIs which internally perform functions and give some output, some usable output to other developers and businesses. So if I were to map these technical documents to OOAD concepts, I would say something like this. So an overview document is like identifying the requirements at the system level. You define what the product or what that particular piece of software does in the overview. So the overview section, when you read the overview section of an existing software or of an existing product, or you want to write a new overview document, you could think of the requirements that the system fulfills that the system fulfills as a whole, the solution that it provides to the customer, or what problem space does this software address. So we can write the holistic view of the solution in the overview section. The quick start guide is then interaction between the product and user, because we want the end user to start using our product with minimal configuration as quickly as possible. So we elucidate these steps as crisply as possible in a quick start guide, so that the end user can get up and running with our product. So here the keyword is interaction. So in a quick start guide, we are basically writing the interactions that a user can perform with the product. So it gives you an idea, it gives you a perspective from the product point of view and from the end user point of view. What are the operations that an end user can perform, and what are the operations that the product can perform? So this is what the quick start guide does, and this is how we can map it to OOAD concept. And then there are tutorials and how to guides. Again, this is about interaction, but here we might delve deeper into interaction between objects of that particular software system. So how do various parts or objects of a product, of a software, interact with each other? We explain that all in great detail in tutorials and in how to guides. And then there are concepts or reference guides, which I would which I would equate to the object model, because you explain a concept, you explain the attributes of that concept, or you explain the highlights of the concept, and you explain the workings of that concept. So in a nutshell, in an object model, you have attributes and the functions that an object performs. In a similar way, you could think about the concept documentation or the reference documentation. First crisply define the features or the attributes of a particular software, and then define what operations that the software can perform. And then of course the new age API documentation, which is nothing but a collection of request attributes, response attributes, and the API itself describes how does the end user interact with the system. Right. So the goal of this slide is just to map various kinds of documentation that we develop to object oriented analysis and design concepts, so that next time we start writing such a document or we start reading such a document, we can map whatever we are reading to object oriented concepts. So, as I've said, object is at the center of object-oriented analysis and design. And we identify and define objects in the problem domain, and we use those objects to tell a story. After all, we are technical writers, and we are writing the specifications or the way to use a software. And if we can develop a story out of it, it would obviously mean that the end user or our audience will be able to understand it better. But yeah, I don't want to harp much upon the story aspect of it, but the story would comprise of the attributes, the actions, and the interactions. For example, this online meeting, we are sitting in an online meeting right now, and there are many objects involved in this online meeting as well. So there is this computer. This computer is running an operating system. On top of that operating system, a web application is running. In our case, it is Teams. And then there is the end user, which is you and I, and we are connected through the internet. So each of these objects, now just imagine the capabilities of each of these objects. I'm sure that you can right now, you must be thinking that what are the attributes of a computer? A screen, a keyboard, a sound, a microphone through which the voice is coming. You might be using a peripheral device like a headset through which the audio input is going into your ears. So these are the attributes of a computer. And then what actions is it performing? It is displaying the output. It is outputting the sound. It is allowing you to toggle between applications using Alt Tab, and it is performing so many other operations under the hood. Similarly, the operating system would be too deep, but yeah, the primary work of the operating system is to act as a glue between the application and the hardware. So the operating system is the piece of software which is running between the web-based application, that is Teams, and the motherboard of your computer. And that is how the entire that is how the entire system has been designed, so that we could receive input from Teams and send input to it. All right. And then of course there is the end user and the internet. So really, I again, with this real time example, I really want to highlight that we have to start thinking in terms of objects, attributes of those objects, the functionality or the actions that the object can perform, and how that object is interacting with another object. All right. So you can define each of these objects in greater detail by specifying attributes, actions, and interactions. So let us now look at a very quick formal definition of object-oriented analysis. Herein, we investigate the problem, identify and describe objects in the problem domain, whereas design is considering the result of analysis and defining software classes. This is where we actually start going towards implementation phase, and we define software classes and how they relate to each other. All right then. Up until now, if there are any thoughts that anyone wants to share, or any questions, you can share it on chat, or just say it out loud. All right, I had in my mind given you 3 seconds to speak up. 3 seconds are over. We'll move on. So again, let's get to the writing part of it, or to the English language part of it. So we can use natural language to develop object model. Remember that our goal of visualizing object is to then develop an object model, and we can use natural language, that is English language, to develop that object model. So, so you could think of the proper nouns as the object, the common nouns as the class, the doing verbs as the operation, the being verbs as inheritance, and the having verbs as the aggregations and composition, and the adjectives as the attributes of that class or of that object. So, if you are reading a documentation, you could underline the parts of speech in that use case or in that existing documentation, identify the proper nouns, common nouns, different kinds of verbs and adjectives, and that will actually help you understand how the system has been segmented into various objects and various classes, or various actors which are interacting with each other. So this is where I see commonality between software development and technical writing, that we can use this common natural English language and the parts of speech of English language to actually make an object oriented model, or to build the object model of a particular software. All right, then. So let's move on. Let us look at this ATM session use case. This is commonly available on the internet. The nouns have been highlighted in green, and the verbs have been highlighted in blue. Or if you could come up with a better description of this color. So a session is started. Anyone, I mean, if Anshita would want to read what is present on my screen. Anshita, I welcome you to, just read out what's written.
Sure, sure. So, example ATM session use case. A session is started when a customer inserts an ATM card into the card reader slot of the machine. The ATM pulls the card into the machine and reads it. If the reader cannot read the card due to improper insertion or a damaged stripe, the card is ejected and an error screen is displayed and the session is aborted. The customer is asked to enter his/her PIN and is then allowed to perform one or more transactions,
Hmm.
choosing from a menu of possible types of transaction in each case. After each transaction, the customer is asked whether he/she would like to perform another. When the customer is through performing transactions, the card is ejected from the machine and the session ends. If a transaction is aborted due to too many invalid PIN entries, the session is also aborted. With the card being retained in the machine, the customer may abort the session by pressing the cancel key when entering a PIN or choosing a transaction type.
Thank you so much. Thank you so much, Anshita. So what Anshita did right now was read out this use case. Now you, I'm sure, must be presented with use cases on a daily basis. You must be reading requirement documents, specification documents. You might also be reading high level diagrams in order to translate them into technical documentation. And use cases are a common theme, whether you are reading a high level requirement specification, or you are reading a high level design document of a particular software. So So really, I already, although I have already highlighted the nouns and the verbs, but what we will see in the next slide are how we can, just based on natural language analysis, define objects, define classes, and the actions that they can perform. So Anshita, since you read this particular use case, can I ask you what can the customer do with the ATM machine? Just one or two things that the customer can do with the ATM machine.
Money transaction.
Based on this, if you were to just pick up words from this use case that you read, what would you say? What can the customer do how with the ATM machine? So basically, customer can insert an ATM card into the machine, can insert an card. So inserting the card itself is an action that the customer is performing. And when this action is performed, some processing logic is triggered in the ATM machine, and some more things happen. The rest of the flow happens. All right, we have got Honey Jan as well with us. So Honey, again, don't think of this as a quiz, just want to make it a little interactive. The very first word in this use case is session. So Honey, if I have your attention.
Yes, Deeptendu.
So what are the attributes of a session? If I were to ask you, what are the attributes of a session? Just reading this use case, what do you think the attributes of a session are? How would you define a session?
Whether it's successful or not,
Yes.
whether uh, it halts, it aborts, all those things, whatever.
Exactly. So success and failure of a session is clearly one output. So a session can be successful or failure, and I could have this as an attribute of session class. That success. So success could be false or it could be true. Honey also used the word aborted, right? So a session can also be aborted. Maybe the electricity supply in the ATM room has been interrupted, and the session had to be aborted. So in that case, the session will also have to be rolled back, which is a concept from databases, right? And so now let us look at the next slide. And really, thank you very much, Anshita and Honey. Really, don't think that I put you on a spot. It's just that we want to make it a little interactive. So the nouns here are. Uh, s- oh, yeah. All right. So the nouns here are session. So the session, Honey has already mentioned successful, unsuccessful, and aborted. So a session can be started, it can be aborted, and it can end. Now look at the word customer. Customer clearly is going to be an object. There has to be a customer class, and the customer can do inserting the card, performing operations, of course, choosing an operation, performing it, and then pulling out the card. See here that I have written the word pin. Now, a pin is something that has to be associated with the customer. A pin does not have an existence or an identity of its own. The pin is not specific to a customer. It is a pin and account number combination which makes a unique key. But then a pin can exist only when there is a customer. Similarly, a stripe. Stripe is also a noun. It is an object. So yes, we can have a class stripe, but that class will not have any meaning until and unless there is an ATM card. So that is how we start modeling when visualizing objects that are present in the system. So the ATM card could be pulled, the machine, the entire system that we are dealing with, the card could be ejected, it does processing, it displays output, it allows and disallows certain functions. So through this slide, or what I'm trying to get at is, first of all, splitting the nouns and verbs, and then trying to map those nouns with the verbs. So the session class or the session object should be able to start, it should be able to abort, and it should be able to end. The machine class or the ATM class should allow for ejection, display, reading of cards, so on and so forth. So this is how we can start visualizing a system, right? And we will now move on to. Okay. All right. Hmm. All right. So what we just did, this was just a natural language analysis. This is an analysis based on intuition. It is an analysis based on your understanding, your command over English language. It is an analysis based on how the existing use case has been written by the SMEs and by the architects. So it is not a formal, I would call it an informal method. But yes, we being writers, and since we have got good command over language, I think we can really do natural language analysis better than a software developer who might not be as comfortable in English language as he or she is in C++. But again, the software developer community, please don't take it as an offense. But there has to be a formal way of doing anything. There has to be an intuitive way of doing things. There has to be a formal way of doing things. Only then we can get the best results. So how can we identify or analyze the use case in details? So this is just a small template. So identify the actors, anyone or anything that performs a behavior. Clearly for ATM, the customer would be my primary actor. So primary actor is the stakeholder who initiates an interaction with the system to achieve a goal. So customer is the primary actor. The ATM machine itself is another primary actor. Right, then we have the stakeholder, someone or something with vested interests in the behavior of the session, of the system. It could be, say, the bank employee who might keep a tab on the operations that are going on in your account, or it could be the income tax department who keeps a track of any suspicious credits and debits in your account. So there are other stakeholders. Then there are preconditions, like what must be true or what should happen before and after the use case runs. So after we have withdrawn money from an ATM card, we are expecting a slip which has the remaining amount in our bank account, or we are expecting a message on the ATM screen that the transaction has been successfully completed, things like that. All right, triggers. This is the event that causes the use case to be initiated. So the act of inserting the card in the card slot is the trigger. And there has to be some main success scenarios and some alternative paths. So main success scenarios, so use case in which nothing goes wrong and you can insert a card and finally extract some money from the ATM machine. And there have to be alternate paths, which are variations from the success scenarios. So these are exceptions to what happens when things go wrong at the system level. The ATM machine might malfunction, the electricity supply might get interrupted, the card might get jammed in the card slot, so on and so forth. So you can use this formal template to analyze the use case that you're dealing with. So let's look at a real life scenario, and this is from the perspective of a point of sale. Often we go to malls and shopping complexes and do some purchase. We might be giving our debit card to the person and to do the payments and all. So from that perspective, in that domain, this real life scenario is applicable, and again, it's commonly available on the internet. I receive paper invoices with the checks attached to them. I enter the invoice number into the system and pull up the record of sale. I then enter the payment information into the system, including the payer's name and address, check number, date received, amount, checking account number, and routing number. So you can imagine this real life scenario is from the perspective of someone who is taking payment from you, the buyer of a particular product. And we could crystallize this real life scenario into a use case. So the system displays a screen that allows user to enter an invoice number. The user feeds invoice number into the system. The system accesses the sales record and displays current information in the record to the user, highlighting fields that are related to payment. Now the user types in information into the fields and submits the updated record. The system updates the sales record. Right. So again, this crystallized use case, or you could read the real life scenario, identify the objects, identify the operations, the verbs that are present in the real life scenario, and then probably you could come up with your own version of the use case and see how does it match with the use case provided in the HLD or in the requirement specification document, or the way the SME has described it. It would probably increase your own confidence in the work product that you are creating and would certainly result in a better quality of documentation. So again, just a continuation of the previous whatever we saw on the previous screen. So the actor here are the data entry worker and the system. The stakeholders are the data entry worker and the bank. The trigger and the preconditions are that there is an active network connection, the internet connection between the data entry worker and the sales record database. The main success flow would be the use case begins when user enters an invoice number into the search screen. The system retrieves the sales record and displays the information to the user. The system highlights the area related to payment information. Payment fields are then indicated and the user submits the record to the system. Here again, I have highlighted the actors or the objects or the nouns in green and the verbs or the actions in blue, so that you can again map it to the natural language analysis. So basically what I want to encourage is using formal methods of use case analysis with a heuristic or intuitive method of use case analysis that is based on natural language. Use both these techniques to come up with your own way of identifying, analyzing and ripping apart use cases so that you can identify objects and write better documents. The alternate flows is that the invoice number could be invalid. User attempts to submit the record before all payment fields are filled, so that would result in an error, or you enter an invalid information, so on and so forth. And there could be successful completion or a failed completion, and you can refer to the details later on. Right. So, up until now, anything that you would like to discuss or talk about, or any thoughts, any questions up until now from anyone?
Also, we have just 5 minutes to start with Q&A.
Correct.
Yeah,
Exactly. So it's 11:30, and I've got 5 more minutes to wrap this thing up. Yeah.
yeah.
So, all right. So, yeah. So moving on, we are using Google Maps on a daily basis. Can't really step out of the home without a phone and with the internet connection and with Google Maps on, with the destination locked and loaded. So we are living in the world of API, and API documentation is so common, so pervasive, so important these days, right? So I have picked up these code snippets from Google Maps website. I will share the link to it afterwards, or you could just pick up keywords from this slide and search it on Google, and you'll find the same data. So the Google Maps API on their website, this is what they've written, that this documentation is designed for people familiar with JavaScript and object-oriented programming. You should also be familiar with Google Maps from a user's point of view. And this is a conceptual documentation designed to let you quickly start exploring and developing application with Maps. Maps JavaScript API. So this is Maps JavaScript API documentation. And I'm sure that many of you would have written something like this, uh, or must be writing a document like this in your day-to-day work as well. So again, this slide serves two purposes. One, object-oriented programming concepts are helpful for technical writers as well. And then, of course, this is how we are going to now study these code snippets, right, to get a little bit more into the programming part of it. So the left part is HTML. So there are two things. There is a web application, then there is Google Maps system. So a web application wants to utilize the Google Maps system. I will give you an example. There is an app known as Routematic, which is used for booking cabs. Oh, let us take the example of Uber. Uber is a web application, and we use it to hail cabs and to visit various destinations. And Uber internally uses Google Maps in order to fetch the geography of the area and calculate distances and all. So imagine that you have got a web application. A web application will have HTML, CSS, and JavaScript. On the left side, you can see this HTML snippet. In this HTML snippet, you can see this script, and in the script you can see that the key is this callback is equal to init map. This is where we reference the JavaScript code base, right? And on the right, you can see the JavaScript function. We are doing init map. So map is equal to new something, new map, and new is a keyword which is used to create a new object. So here map is the class, new means you are creating an object of the class, and you are saving the reference of the class in the reference variable map. And then as you can see, this map or has got attributes like center and zoom. So what will be the latitude and longitude attributes, what will be the zoom percentage of the map. So these are the objects or the attribute, these are the attributes that you are specifying for the map object. And every object of course can have different values for these attributes. So here you can see a real life example of a class of an object and of the attributes of the object being defined, and then how this object model is being embedded into a web application or into a separate application. And the capabilities of map object or map API will now be leveraged. So here I can see two big entities: web application, Google Maps. Inside Google Maps I can see this map API, and map has got attributes like center, zoom, so on and so forth. Basically I'm trying to again reiterate objects, various kinds of object interactions between objects and attributes of those objects. So map DOM elements. Again, here, what is DOM? DOM is domain object model. So as we saw in the HTML, we can see that div map div. So div is a space in on the HTML page, and we have given it the ID map. So on an HTML page, imagine HTML page to be an object, or imagine HTML page to be a class. We have divided that class by geography. So there is going to be a header, a footer. The center part is going to be a map. Inside the map, I'm going to show a car, the and the geography, the road map, and a car which will be following its intended path. So you could even imagine the HTML page to be like an object. Divide the HTML page into categories, have attributes and behaviors for specific pages of an for specific parts of an HTML page. That is why I have mentioned map DOM elements here. And map options, I have already mentioned center and zoom are attributes of map. All right. So after attributes, I know it's 11:35, but I'll take just 2 more minutes and wrap this up. So you can see the libraries which are applicable to map, and just Google it and you'll find Google Map API and Google Map libraries, and you'll find all these libraries. I want to highlight the geometry library. Inside geometry library, you will find static methods. So methods or operations which this class as a whole can perform. And then you will also be able to see what is init map, what is this map API doing under the hood. And you would ultimately find out that various kinds of events are being performed, attributes are being defined, so that we can give the correct output to the user. And I mean, I have to be cognizant about time, so I won't go into much depth. And just to wrap up the presentation, uh, I want to wrap up this presentation with the core principles of object oriented programming, which is abstraction. So you focus on the essential details and leave out the implementation details or under the hood features of an object or a class. That is what abstraction means. And encapsulation is again binding object and object attributes and the function, binding data and function and exposing them through interfaces, which is APIs. Then modularity, thinking about a system in object oriented terms allows you to modularize the systems, break the system down into smaller and smaller part. We would want to break the system down into smaller parts because we want to lose coupling between various parts of a system. And coupling and cohesion are two concepts. So we want one module to be cohesive, but but the coupling between different modules has to be loose and they should not be tightly coupled, so that dependency between different modules is not a limiting factor for the system. And then of course there is inheritance. So I'm sure that you have at least an intuitive understanding of what inheritance means. So it could be like single inheritance or multiple inheritance. One superclass and a base class derives from the superclass, derives attributes and functions of the superclass, and adds its own functionality. That is the core idea of inheritance. And finally, just one more example. YouTube started the movie rental service. So imagine you are the customer and you are watching a movie. You want to rent a movie from YouTube, and YouTube, instead of the physical video store, we have got YouTube. So one customer can rent one or more videos. The customer can rent video from YouTube. So many customers star can rent the same video from YouTube, and the video store, one video store which is as YouTube can store multiple videos. This is how you can actually model your understanding into a diagram, right? And again, just some more words. There could be is a hierarchy. So I mean, so the principal is an employee of a school. The teacher is also the teacher is an employee of the school. So employee could be principal and teachers, part of, and then there are associations, one to one to many, and many to many. We can have compositions. So a student, the student data is composed of address. So this is what composition means, but the address is a class in itself and can stand on its own, right? Aggregation, we looked at the example of PIN and ATM card. So Stripe and ATM card. So imagine instead of course, I have written Stripe, and instead of student, I have written ATM card. So if ATM card, the Stripe cannot exist on its own, but yes, it forms the ATM card as a whole. And that's about it. I had to rush to the last few slides, but really, the goal is for us to start visualizing the world in terms of objects, attributes, features, and interactions. And I hope that this perspective helps you build better documentation. And that's about it. Thank you very much for your patient listening. Back to the hosts.
Yeah, thanks, Deeptendu. This was really a wonderful session. Now it's time for question and answers. So anyone wants to unmute and ask question because I cannot see anything on the chat.
Hi, Deeptendu. I would
Hi.
like to ask something like you have covered a lot of concepts related to OOPS and OAD, and so I just wanted to know, like, to what extent OOPS concept a technical writer must understand or a technical writer must know.
Okay. So I'll give an example from my organization, or I mean, applicable to anyone. We clearly uh, rarely do we write documents from scratch. Yes, we do, but we do have some reference of existing documentation as homework, as our own as our own backend work. We can read existing documentation, do object perform object oriented analysis on that documentation, which helps us write new documentation. And that is how I think a technical writer can leverage or can take advantage of these object oriented principles. Because an organization wouldn't be doing radically different work. They would probably be adding some more features to an existing product and spinning off a new one, and so on and so forth. So if you can understand one domain's documentation, apply OOAD principles, and understand the objects and interactions, then you could apply the same concepts when you're writing a new document. And this is that's the whole point of studying this subject.
Thank you so much.
Yeah, I have one question. So, can you share some resources that will help us understand more about it?
More about object oriented programming?
Yeah, yeah.
Sure. I will share some resources. I will suggest some books which you
Hmm.
can just read on in your free time and get some understanding. Yeah, I'll do that.
Okay. And also how to apply these principles while we are documenting. Though you covered a lot, but just more grasp of it.
Sure. Maybe I can come up with some sort of case study where I apply these principles to an existing documentation and just show this to you in action in more detail. Yeah.
Okay. Okay, so Gaurav has a question. At what doc phase do you think we need to come up with this analysis? Requirement
Yeah.
gathering? Yeah.
Yes, thanks. Yeah, I think this question is very relevant. So, this should be done when you are interacting with subject matter experts and you get some input from them. So, there is some analysis that you do before talking to the developer. You talk to the developer, go back and prepare the document, and then get it reviewed back. So, I think the perfect time to do this kind of an analysis is after you have had one interaction with the developer, because then you have got specification documents are available to all, be it technical writer or developer. Then HLDs are available to the developer, but not to the technical writer. So you would get the HLD probably when you start interacting. So now that you have got high level documents, an HLD, you perform object oriented analysis on that, write a document, and then get it reviewed. So I think perfect time would be when you are in that part of the release when you are talking with the subject matter expert.
Okay. Another question is that how can these help in UML diagrams?
All right. So we talked about a lot of theory, and all of this theory can, the way to map this theory into something visual is UML diagrams. So I could just show one example of a UML diagram, but all the theory that we have talked about, the interactions, the actions that an object can perform, the sequence in which operations perform, we, there are various kinds of UML diagram which map to each phase of the object oriented analysis, something that I can, make as an addendum to this presentation and share with the group later on. And the same could be just blindly used in a document. I mean, if it makes sense to everyone.
All right. So I can see that we have no more questions. If anybody wants to proceed with the questions, then they can post that in the global Telegram group or else in the chat also. Deeptendu will be answering them soon. So thanks, Deeptendu. This was really a wonderful session. A lot of complex topics, just got covered in a very easy to understand way. So thank you for that.
Thank you. A pleasure of mine. Thank you very much.
Yeah.